Hello and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of prime factorization and order of operations. This is standard 6.7a in the great state of Texas, and we are using item number 21 of the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So it's a fairly straightforward problem, but it is a free response because there are no A, B, C, or D choices for us to choose from. We need to show the prime factorization of 90, and they actually give us the beginning of it. 2 times 3 squared times a missing factor. That's the number that we need. Now, if you do not know what prime factorization is, we actually have 2 clues here. First, we see this word factor, and so factor lets us know that we are dealing with a multiplication. A factor is a number that you multiply by another factor to get to a product, like 3 times 4 equals 12. 3 and 4 are both factors. Another way that we could figure that out is simply because we have these multiplication symbols right here. These dots right here, these are not decimals. Those are multiplication symbols. So how do we come up with prime factorization? Well, we need to know the difference between prime and composite. So prime numbers only have 2 factors. So it's going to be 1 and itself. So let's take a look at the 2 prime numbers that we see here. So 2. The only way to get to 2 is 1 times 2. There's no other way to multiply to get to 2. So it's got 2 factors, 1 and 2. Same with 3. 3. The only way to multiply by 3 is 1 and itself. Now, if we were to get to 4, so composite is 3 or more factors. So a number like 4 is going to have 3 factors, because you can make 1 times 4. You can also do 2 times 2. And even though it is 2 times 2, what we do is we just list that 2 once, so you'd say the factors are 1, 2, and 4. So that's what we're looking for. Let's break down 90, and let's see if we can come up with prime numbers. So let's start with, there's going to be multiple ways we can do this. So let's start with 90, and let's just start with probably one of the easiest facts here, which is going to be 9 times 10. Now, if either of these numbers are prime, we're going to circle them. That's why sometimes it looks like a Christmas tree, because they're ornaments. But 9 is not prime. It's composite because I can think of a way to get to 9, multiply to 9 without 1 times 9, and that's 3 times 3. So this is where you have to know your multiplication facts. If you don't know your facts, then prime factorization is going to be a lot of hard work. Now those are both prime because we've already figured the only way to get to 3 is right here, 1 times 3. And how do I multiply by 10? Well, the only way to really multiply by 10 is 2 times 5. Or 1 times 10. But 2 times 5 is going to make it, these are 2 prime numbers here. And we're done, because 5, I'm going to go ahead and add 5. The only way to multiply to 5 is 1 times 5. So that's another prime number. So once you have all circles or all ornaments, you're done. So you list them in order, and you say 2 times. Now you don't say 3 twice. What you do is you list it once as the base, and then you use an exponent to say how many 3's are there. There's 2 3's. So this 3 squared, or 3 to the second power, literally means 3 times 3. And then times that 5. So it looks like our missing number is going to be 5. Now let's see what happens if we do it a different way, because there's many different ways we can get to 90. You can do 3 times 30. So 3 is going to be prime, and then you can do 6 times 5. 5 is prime, and then you do 2 times 3. So guess what you get? 2 times 3 squared times 5. That's the cool thing about prime factorization. Doesn't matter how you break up the initial factors. You could even do 45 times 2, and you'll still get the same numbers. So that's going to be 9 times 5, and you see where we're going here, 3 times 3. So this is also going to give us the exact same way. There are different ways that we can do it, but it's always going to show up as the exact same set of factors. 2 times 3 squared times our answer, 5.